Hello everybody, I'm Abasud and welcome to my course on IoT cybersecurity and risk management. So today we are continuing with the pre-market phase activities of manufacturer. So let's start with activity number 3. Let's talk about determine how to address the customer needs and goals. So after researching the cybersecurity needs and goals of an IoT devices, expected customer and use cases, manufacturer can determine how to address these known end goals in order to help customers mitigate cybersecurity risk. For each cybersecurity need or goal, the manufacturer can answer the questions: which one or more of the following is suitable mean or combine or means to achieve the needs or goals. The IoT devices can provide the technical meaning through its device cybersecurity capabilities. For example, by using the device cybersecurity capabilities built into the cybersecurity operating system, or by having the device applications software provide device cybersecurity capabilities. Another device related to IoT devices can provide the technical mean on behalf of the IoT devices. Other systems and the services that may or may not be acting on behalf of the on behalf of the manufacturer can provide the technical meaning. In addition to and support to technical meaning, non-technical meaning can also provided by the manufacturer and the other organization and the service acting on behalf of manufacturer, like communication of lifespan and support expectation, disclosure of flow remediation plan. The customer can select and implement other technical and non-technical mean for mitigating cybersecurity risk. The customer can also choose to respond to cybersecurity risk in other ways, including accepting or transferring it. Next question can be: how robust must each technical meaning to be implemented in order to achieve the cybersecurity need or goal? Robustness of a technical means refer to the overall strength of the means implementation and is related to the trust a customer may expect to in their IoT devices. If a device is expected to be more trusted by a customer, particularly to remain in a secure state and stay outside the control or access of unauthorized entities, then it is likely that the technical meaning implemented on or with that device will have to be more robust. Here are some examples of potential robustness consideration: whether it needs to be implemented in hardware or software, which data needs to be protected, what type of protection each instance of data needs, that can be CI address, confidentiality, availability, integrity, and how strong that protection need to be, how strong an entity identity needs to be authenticated before granting access to the entity is a human, like password, paraphrase, multi-factor authentication, system device, that can be through certification, KPI keys. Whether data received by and inputted into the device needs to be validated to confirm the legitimacy of an update. How ready software updates can be revealed if problem occurs. Ultimately, manufacturer can aggregate the technical meaning identified for all the needs and goal to answer the following question: what technical meaning will be provided by an IoT devices itself or other devices related to the IoT devices, other system and services acting on the behalf of the manufacturer and the customers, and how robust should each of these mean by. The rest of the section focusing on the first part. Identifying the cybersecurity capabilities that the device itself needs to be provided should be happen as early as feasibility in device design processing, so that the capabilities can be taken into account when selecting the design of a IoT hardware and software. To provide manufacturing a starting point to use the identify necessary device cybersecurity capabilities for their IoT devices. A companion publication, IoT device cybersecurity capability core baseline, defines a device cybersecurity capabilities core baselines, which is a set of device capability generally needed to support common cybersecurity control that protect the customer's devices and device data systems and ecosystems. And so this was our third activity. Now let's go straight forward to the fourth activity that we are talking about: plan to adequate support of customer needs and goals. So it is important for a manufacturer to consider how to support their identified customer needs and go beyond the selection of specific device cybersecurity capabilities and their high level implementation. This include considering how to provision computing resources to support these device cybersecurity capabilities, and action externally to the device may be required to continue to support cybersecurity needs and goals. So what question we need to ask from ourselves? Considering expected term of support and lifespan, what potential future use need to be taken into account? For example, if a device uh, lifespan is 10 years, it may be necessary to update the encryption algorithm or key length the device uses during that time, and the new algorithm or keys length may require more processing resources than the current algorithm or key length. Considering how the device can support the cybersecurity needs goal of the device lifespan during future proofing of a device cybersecurity capabilities and their implementation. Next question can be asked: should an established IoT platform be used instead of acquiring and integrating individual hardware and software component? An IoT platform is a place of IoT devices, hardware, and supporting software already installed and configured for a manufacturer. Use as basis of a new IoT device. An IoT platform might also offer third-party services or applications or a software development kit to help expedite IoT application development. Manufacturers can choose a sufficiently resourced and adequately secure IoT platform instead of designing hardware, installing and configuring the an operating system, and creating new cloud-based services. Writing IoT device application and mobile app from scratch and performing other tasks that are more error prone and generally more likely to introduce the new vulnerabilities into the IoT devices as compared to adapting the established platform. Next question can be asked: should any device cybersecurity capability be hardware based? Example is having a hardware root of trust that provide trusted storage of cryptographic keys and enabling performer secure boot and confirming device authentication. Uh, further, manufacturers should consider whether those hardware based capabilities will be updated. So in some cases, customer will need an immutable hardware root of trust and never should update or change to a functionality, but such limitations could be detrimental to an ongoing securability of other customer. And next question we can ask: does the hardware or a software include unnecessary device capabilities with cybersecurity implications? So if so, can they be disabled to prevent misuse and exploitation? So a device may have a local interface on its external housing that are useful or essential for some of future expected use cases, but the device may be deployed in a public area by some expected customer where those interfaces would be exposed to possible attack. Possible approaches to this issue include offering temper resistance enclosure to prevent the physical access to the interface, and offering a configuration option that locally disable the interfaces. So this is what we are having in our pre-market phase can be done. There were few activities that can be done in the post-market phase that we'll be discussing in the coming sessions. Thank you.